If you want to see more topics, then check the playlist section of this channel. Also, if you want to buy my notes, then check the link in the description below. In this video, we will see an example on sinusoidal steady state analysis, nodal analysis. Question: by nodal analysis, obtain current I/O in the circuit of figure. So here for this circuit, we have to find the value of this current I/O by using nodal analysis. So first of all, we will take this circuit from here. Now here let's assume this as a reference node or ground node. Let's say this is a node with voltage V1 and this is node 2 with voltage V2. Now here this node voltage will be this much because it is connected to ground. So this node and this node, it is a single node, so its voltage will be 100 at an angle 20 degree volt. So let's assume this current is current I1, this current is current I2, this current is I3 and this current is I4. So now we will apply KCL at node V1. So let's apply KCL at node V1. Summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now here we can see at this node entering current is this I1 is the entering current. So let's write I1 is equal to now leaving current at this node, this I2 and this IO. So I2 plus IO. Now let's write this I1 in voltage form. So it will be this node voltage is 100 at an angle 20 degree minus V1 divided by J4. So 100 at an angle 20 degree minus V1 divided by J4. It is equal to, now this I2 is V1 minus 0 divided by 3. V1 minus 0 divided by 3. Then plus IO. So it is V1 minus V2 divided by 2. V1 minus V2 divided by 2. Now let's simplify this. So it will be 100 at an angle 20 degree divided by J4, then minus V1 divided by J4. Then we can take this on left side. So minus V1 divided by 3, then minus V1 divided by 2, then this will be plus V2 divided by 2 is equal to 0. So here we can take V1 common. So V1 in bracket minus 1 upon J4, minus 1 upon J4, then minus 1 upon 3, then minus 1 upon 2 plus V2 in bracket 1 by 2 is equal to, now let's simplify this, 100 at an angle 20 degree, 100 at an angle 20 degree divided by J into 4. So it is 8.55. So on right side it will be minus 8.55. Then here it is minus, so it will be plus 23.49 J. 23 plus 23.49 J. Now let's simplify this further. So it will be V1 in bracket minus 1 upon J into 4 minus 1 upon 3 minus 1 upon 2. So it is minus 5 by 6 minus 5 by 6 minus 5 by 6 plus 1 by 4 j plus V2 into 0.5 is equal to minus 8.55 plus 23.49 j. Let's assume this as equation number 1. Now similarly we will apply KCL at node V2. So let's apply KCL at node V2. Now again summation of all the currents entering a node is equal to summation of all the currents leaving the node. Now at node V2 entering current is I3 and IO. So I3 plus IO is equal to I3 plus IO is equal to I4. Now I3, here we can see I3 is this node voltage, it is 100 at an angle 20 degree minus V2. 100 at an angle 20 degree minus V2 divided by 1, then plus IO. So IO is V1 minus V2 divided by 2. V1 minus V2 divided by 2. Then is equal to I4. So I4 is V2 minus 0. V2 minus 0 divided by V2 minus 0 divided by minus J2. Minus J2. 100 at an angle 20 degree minus V2, then plus V1 divided by 2 minus V2 divided by 2, and if we take this on left side, so it will be minus V2 divided by minus J2 is equal to 0. So here we can take this V1 common. So V1 in bracket 1 by 2, then plus V2 in bracket minus 1 minus 1 by 2, then minus 1 by minus J2 is equal to, now here if we convert this polar form to rectangular form, 100 at an angle 20 degree, so it is 93.96. It will be minus 93.96 minus 34.20 minus 34.20 J. So V1 in bracket 0.5, this is 0.5 plus V2 in bracket minus 1, then minus 1 by 2 minus 1 minus 1 by 2 minus 1 upon minus j into 2, bracket complete, it is equal to minus 1.5 minus 1.5 minus 0.5 j is equal to this much. Let's copy it from here. Now let's assume this as equation number 2. So we got two equation 1 and equation 2. So solving equation 1 and 2. So let's put this in matrix form. So from equation 1 it will be this value. From equation 2 it will be this value. From equation 1 it will be this value. Then from equation 2 it will be this value. And here two unknowns which are V1 and V2. So it is equal to from equation 1 it is equal to this, and from equation 2 it is equal to this. Now let's find the value of delta. So delta is equal to, we have to take the determinant of this matrix. So let's take the determinant of this matrix. So we have to multiply this term into this term minus this into this. So let's solve this. It is equal to this term multiplied with this term. Then minus 0.5 into 0.5. It is equal to the value of delta. Minus 5 by 6 plus 1 upon 4 into j. Then multiplied with minus 1.5 minus 0.5 into j minus 0.5 into 0.5. So it is 1 point, or simply 9 by 8, 9 by 8 plus 1 by 24j. So this is the answer for delta. Then next we have to find the value of delta 1. Again, to find the value of delta 1 we have to take the determinant of this matrix, but now this time we have to replace its first column. So let's replace its first column by this value. Let's copy it from here. Let's rewrite this matrix again. So first we have to take this column. Then next we have to take this column. So it is equal to, so this multiplied with this. Let's take this from here. Now we have to multiply this with this value. Now next we have to subtract this. Now this time we have to multiply this into this. So let's copy it from here. then multiply with 0.5. Let's solve this in calculator. So it will be minus 8.55 plus 23.49 into j multiplied with minus 1.5 minus 0.5 into j, then minus 93.96 minus 34.20 into j multiplied with 0.5. So it is 71.55 minus 13.86 minus 13.86 j. So this is the value of delta 1. Then next the value of delta 2. So for delta 2 again we have to take this matrix determinant, and now this time we have to replace its second column. So now if we replace this second column by this value, so this into this, let's copy it from here. Then we have to multiply this with this value. Then minus 0.5 multiplied with this value. Let's copy it from here. Now it is equal to the value of delta 2. So let's solve this in calculator. Minus 5 divided by 6 minus 5 by 6 plus 1 upon 4 into j, then multiplied with minus 93.96 minus 34.20 into j minus 0.5 multiplied with minus 8.55 plus 23.49 into j. So it is equal to 91.125, 91.125, then minus 6.73 j, 6.73 j. So this is the value of delta 2. Now we can find the value of V1. So V1 is equal to delta 1 divided by delta. The value of delta 1 is, this is the value of delta 1, divided by the value of delta. The value of delta is this. So V1 is equal to 71.55 minus 13.86 into j divided by 9 by 8 plus 1 upon 24 into j. 9 by 8 plus 1 by 24 into j. So it is this much in rectangular form. In polar form this will be shift 2, 3. So 64.73. 64.73 at an angle minus 13.08 degree volt. So this is the answer for V1. Then next we have to find the value for V2. So V2 is equal to delta 2 divided by delta. Now the value of delta 2 is, this is the value of delta 2, divided by delta. Delta value is this much. V2 is equal to 91.125. 91.125 minus 6.73 into J divided by 9 by 8 plus 1 upon 24 into J. So in polar form this will be shift to 3. 81.16 at an angle minus 6.34 degree volt. So this is the answer for V2. Now we got V1 and V2, but here in this problem what we have to find? We have to find the value of IO. So here we can see IO is equal to V1 minus V2 divided by 2. So let's copy this from here. So IO is equal to V1 minus V2. So V1 value is this much. Here we will write V1, then minus V2. This is the value of V2. V1 minus V2 divided by 2. So therefore IO is equal to 64.73 at an angle minus 13.08 minus 81.16 at an angle minus 6.34 divided by 2. It is equal to this much in rectangular form. In polar form it will be shift 2 and 3. So 9.25 at an angle minus 162.10 degree ampere. So this is how we can find the value of IO by using nodal analysis. Don't forget to check out the other videos on this channel, and thanks for watching.